Hi everyone, I'm Michael. Welcome to the nullmicgo channel. In this video, we'll go deep on what Agent2Agent is also called the A2A protocol. We'll cover not just the definition, but also some background history and why this matters for the future of AI agents. In one sentence, A2A is an open standard that lets different AI agents use the same set of rules to talk and work together. Just like people need a common language to communicate, agents need a common protocol to collaborate. I'll break it down section by section. First, a bit of background. The AI that companies and individuals use today is no longer just ask one question, get one answer chatbots. More and more of it is agents that carry out tasks on their own, booking flights, doing customer support, reports, hiring, supply chain planning. These agents call tools, look up data, and talk to other systems. But here's the problem. Agents built by different companies, Google, Microsoft, startups, open source frameworks like LangChain and Crew AI, each use different interfaces and formats. Without a common language, they can't discover each other, delegate tasks, or finish a big job together. The result, every agent becomes an island, and the companies that want multiple agents to work together have to build a lot of custom glue code and often get locked into a single vendor. So how do agents talk to each other? Became a very practical question for the industry. A2A was created to answer it. Next, a bit of history. Multi-agent systems, new academia and industry have worked on them for years. There were early standardization efforts, like FIPA, the Foundation for Intelligent Physical Agents, which defined how agents interact using communicative acts and protocols. But agents back then were very different from today's LLM-based agents. Intelligence lived mostly in external rules and data, not inside a large model. So those old standards don't map well to current AI agents. In recent years, large language models and agent frameworks have exploded. Agents can understand natural language, plan steps, and call APIs and tools. But interoperability standards didn't keep up. Everyone built their own APIs and message formats with no widely agreed way for agent to talk to agent. On the 9th of April 2025, Google publicly announced the Agent2A protocol and brought in a large part of the industry, Microsoft, and more than 50 technology companies and partners, including Atlassian, Salesforce, SAP, ServiceNow, LangChain, MongoDB, PayPal, Cohere, Intuit, and consultancies like Accenture, BCG, Capgemini, Deloitte, McKinsey, and PwC. They made A2A an open standard. The spec and implementations are open source. For example, Apache 2 on GitHub, so anyone can read and contribute. Google also said it would work with the community and partners to ship one release in 2025 for production use. So A2A isn't one company's product. It's a shared set of rules with a clear timeline and ecosystem. So what is the Agent2Agent A2A protocol exactly? It's an open protocol and open standard with a clear goal. No matter who builds your agent or which framework they use, Google ADK, LangGraph, Crew AI, Genkit, or others, if they follow A2A to expose themselves and call others, they can safely communicate, exchange data, delegate tasks, and get work done with any other A2A compliant agent. The key point, A2A doesn't specify how agents are built internally, what model, memory, or tools they use. It only specifies how they speak and exchange tasks and messages on the outside. So different vendors' agents can keep their own tech. As long as the external interface follows A2A, they interoperate. For enterprises, that means they can mix agents from different suppliers and manage them with one standard without logging into a single platform. Why do we need a 2A? In more concrete terms, there are more and more AI agents, booking flights, doing support, reports, hiring, approvals. But if they each do their own thing with their own APIs and formats, they become islands. Example, a company uses vendor A's support agent, vendor B's HR agent, and the vendor C's reporting agent. To have all three run hire to onboard to report, they have to write a lot of bridging code, and every new agent means another integration. A2A exists to break those islands. Agents from different vendors and platforms all use the same protocol for discovery, communication, task division, and handoff. For enterprises, no lock-in to one vendor, easier to manage and scale multi-agent systems, lower long-term integration and maintenance cost, and more focus on business logic instead of getting agent A and agent B to talk. Now, A2A's core concepts a bit more detailed than a typical intro. First, who talks to whom? Client agent and remote agent. In A2A, there are two roles. The client agent is the one acting on behalf of the user. For example, find me qualified candidates or generate a report. It proposes tasks, sends messages, and receives results. The remote agent is the one that receives tasks, does the work, and replies. It exposes an HTTP endpoint that speaks A2A so the client can call it. From the client's point of view, the remote agent is opaque. You don't need to know its internal model, memory, or tools. You just exchanges messages by the protocol. Second, agent card discovery and capabilities. Every A2A remote agent has an agent card, usually a JSON document at a well-known URL. The card states the agent's name and the description, the service endpoint, URL, version, and supported A2A capabilities, for example, streaming, push notifications, skills, what is good at, default, input, and output forms, for example, text, files, and auth requirements, for example, OAuth or API key. The client uses this card to discover which agents exist, pick the right one for the task, and know how to call it securely. Third, task the unit of work and its lifecycle. One collaboration is one task. Each task has an ID, often from the client, and a clear lifecycle state: submitted, working, input required, off required, completed, failed, cancelled, rejected. A task can be quick, one question, one answer, or long-running, hours or days, with human approval or more data in between. A2A supports both, and the status and the results can be updated via streaming or webhook. Fourth, message and part 1. Turn of dialogue and content units. Each turn between agents is a message. Each message has a role: user from the client or agent from the remote. A message contains one or more parts: text part for plain text, file part for files, base64 or URI with name and MIME type, data part for structured JSON, forms, parameters. So it's not just text, images, video, tables, and files can be sent together for multimodal collaboration. Fifth, artifact. The output of a task. The result of a task, for example, a generated report, chart, spreadsheet, or structured data, is an artifact. Artifacts are made of one or more parts and can be streamed incrementally, so you don't have to wait for everything to finish. That matters for long tasks and the user experience. 6. 3 ways to interact: polling, streaming, and webhook. Request. Response polling means the client sends a request, for example, with tasks send and gets one reply. For long tasks, it can periodically call tasks get to poll status until the task ends. Streaming SSE keeps a long-lived connection with server-send events. The remote agent pushes status updates and artifact chunks in real time, so the client doesn't have to keep asking. Push notifications. Webhook for very long tasks, or when a long connection isn't practical, the client can give a webhook URL when the task state changes. Importantly, for example, completed, failed, input needed, the remote agent posts to that URL. So whether it's a short Q&A or a long flow, there's a suitable pattern. Next, how integration actually works, and a few concrete examples. Integration roughly goes like this. 1. The client discovers the remote agent. usually via a well-known URL. Send an HTTP GET to the path /well-known/agent.json on the agent's domain, and you get an agent card JSON. The card gives the service URL, capabilities, streaming, push, skills, and whether off is required. The client then knows where to post and what credentials to send the bearer token. 2. The client sends an HTTP post to that URL with a JSON RPC2 body method, for example, message sender, params, including the message and an ID for the response. Content type is application, JSON. 3. The remote agent processes and returns a JSON RPC response. On success, result may be a task, id status, artifact, history, or message. If the task status is working, the client can later call task_get with the task ID to pull. If the agent card says it supports streaming, the client can use message stream to open an SSE connection for live updates. For very long tasks, the client can pass a push notification config, a webhook URL in the message configuration so the server can post when it's done. End-to-end, it's HTTPS and JSON RPC consistent with existing web infrastructure. Here are 4 concrete examples. Example 1. Simple sync, 1 request and 1 response. Say the client asks the remote agent to tell me a joke. The client uses method message send with a message whose role is user and 1 text part. Tell me a joke. The remote agent replies quickly with a task. It is some UUID, status state is completed, and the artifacts contain 1 artifact with a text part, for example. Why did the chicken cross the road to get to the other side? The client shows that to the user. 1 request, 1 response, no polling, no stream. Example 2. Multi-turn, need more input. The client wants to book a flight. First it sends, I want to book a flight. The remote agent doesn't have enough info and returns a task with status state input required and a message asking where to, from where, and when. The client sends a second message sent with the same task ID and context ID and parts like New York JFK to London Heathrow, October 10 out, 17 spec. The server then returns a task with status completed and artifacts with structured data, for example, booking ref, flight times. Same task. 2 message runs the classic wait for user input pattern. Example 3. Long output with streaming. The client writes a long article describing this image. It sends message stream, not message send, with a message that has a text part and a file part, the image as base64 or URI. The remote agent supports streaming per its agent card, so it opens an SSE connection. First event is task status submitted, then it sends artifact update events for section 1, 2, 3 of the article. Finally, status update with state completed and the final true, then it closes the connection. The client displays as it receives, no need to wait for the full article. Example 4. Very long task with Webhook. The client says, generate a Q1 sales report. It usually takes a while. Notify me when it's done. It uses message send but adds push notification config in configuration. URL is its webhook. For example, https://clients.example.com/webhook/A2A, and optionally a token for the server to send in a header when it posts. The server immediately returns task status submitted or working. Later, when the report is ready, the server posts the task status completed artifacts with the report to that URL. The client's webhook verifies the token, updates the UI, and notifies the user, so the client doesn't keep a long connection or pull good for tasks that take tens of minutes or hours. Summary of this section. A2A integration is discover agent card, send or message stream via JSON RPC to the service URL, receive task or message, then pull stream, or set webhook as needed. With this common format, clients and remote agents from different vendors can actually connect. A2A's design follows a few principles. Understanding them helps see where it's coming from. 1. Embrace agent capabilities. A. 2. A is for agent-to-agent collaboration, not treating agents as plain APIs. It lets agents communicate in different forms, text, files, structured data, and doesn't require shared memory, tools, or context. Each stays independent and collaborates only through the protocol. 2. Build on existing standards. The protocol uses HTTP, SSE, and JSON RPC, so it fits existing IT and developer habits. 3. Secure by default. It supports enterprise-grade authentication and authorization, aligned with common open API auth patterns, so enterprises can integrate safely. 4. Support long tasks and leave updates from seconds to days with streaming and webhook for status and progress, so you don't wait forever to see results. 5. Modality isn't just text. Content can be text, files, images, video, tables, room for future multimodal agent collaboration. People often ask, how is this different from Anthropic's MCP, Model Context Protocol? Will one replace the other? Short answer, MCP is about how one agent gets tools, APIs, and context what one agent uses to do work. A2A is about how agents talk to each other, delegate tasks, and collaborate how multiple agents work together. They are complementary. One governs what tools and data an agent uses. The other, how agents cooperate. Many systems use both MCP for tools and context, A2A for coordinating with other agents. Google gave a hiring example that helps. Say HR wants to find software engineers in a unified interface, for example, an agent space. The user tells their agent find candidates that match this role, location, and skills. The agent uses A2A to talk to other specialized agents, for example, one that searches resumes, one that screens. The user gets suggestions, then asks the agent to schedule interviews. After interviews, they use A2A again to call another agent for background checks. The whole flow is multiple agents using the same protocol to divide work, not one giant agent doing everything. That's exactly the scenario A2A is built for. Right now, the A2A spec draft is open. GitHub has the spec Python SDK and sample code, and it supports different frameworks, for example, Google ADK, LangGraph, CrewAI, GameKit. Google and partners will keep improving the spec in the open with one release planned for 2025 for production. So you can already read the spec, try it out, and contribute. If you want to go deep, follow the community and official update. Summary: Agent2Agent A. 2A is an open protocol for agent interoperability. Google announced it in April 2025 with Microsoft and 50+ technology and services partners. The goal is for AI agents from different vendors and frameworks to discover each other, communicate, delegate tasks, and work together safely and in a standardized way. To learn more, check the official Google intro video, link in the description. Go to Google A2A for the spec and tutorials, or visit google.github.io/A2A and GitHub for the spec and samples. If this video helped you, please like, subscribe, and turn on the bell for the nullmicgo channel. Thanks for watching, and see you next time.